Today's episode is made possible through the resounding support of dozens of people just like you on Patreon and the great and powerful Mr. Robert Lopez. If you're interested in being a part of this, check out the links below in the description. You could help these videos happen and be hanging out in our massive online community. Thank you. Hi there guys, welcome back to the shop. Today we're here for episode 25 of Project Archi. Now, this is where things are going to get weird because up until this point, I've stayed exactly on the book. Like I have a copy of the instruction manual made by Chris Annan, who did actually a really good job of making the manual. It's quite impressive and it's got a lot of good pictures in it. But I have a technical difficulty, and this is what's been holding up episode 25 for way too long. Because a while back, we 3D printed some parts for the base. And the base printed fine, the box printed fine, everything was totally cool. And then I didn't use my 3D printer for a couple months, and it got upset. So this is what's coming out of my 3D printer at the moment. And it's not happy. Like just, that's a lot of ugly. So this was my my first attempt at printing it, and well, that's how tough it is. It just comes right apart to layers. Now I'm sure there's a lot of you out there who could help me with this, and I totally support that. Get in the comments or get in the Discord. There's a link below in the description to the Discord, and that's all the people that hang out up here during the live shoots and we do this. And oh dear God, would I love your help with that. But I have printed several of them. I fixed the fuzzy peel apart because I used the other 3D printer, and these are not adhering. In fact, if you look close, you can see, get out of my way. You can see how that bows up at the end. See the bow by my thumb? It looks like I'm squeezing it. And I'm getting that to varying degrees across all of these. This one's particularly bad. That's the worst one. And I have a whole stack of these that are screwed. So what I'm going to do, because all of this is just for the protective shroud that guards the chain. Right here, there's a shroud, a cover plate. And there's the lower covers, that's these, and the outer cover and the logo piece. And I did so much work. Ray Jan, thank you for helping me out. We did a ton of work on designing a custom cover plate that instead of just AR3 actually says ARchi, which is the name of my robot. And that's all unique to mine. All this work done, we can't make it print. And it's killing my soul. So what we're going to do is we're going to jump to the next step in the manual, and we'll come back to the cover plate. For right now, you don't need it. If you can do it, follow the book, go nuts. You'll get ahead of me, which really isn't hard to do because it takes me a long time to make these videos. But for today, we're going to jump forward to the J3 limit switch, and we're going to install that. So we get to do a little bit of electrical, and we're going to do a bunch of electrical over the next couple of videos. I've been looking ahead in the manual, and it's stuff I can do here because I wanted to get more robot videos out because there's a lot of people around the world right now stuck in quarantine. I want to give you guys something to do. So let's hang out and do this. So today we're going to do the J3 limit switch, which is that little bugger. You're going to need an SV166-1C25 roller tip limit switch, because those are the best. And we've played with these before. We've installed these on here before. We're just up to the joint 3 now. So you're going to need that. You're going to need a few crimp connectors. You're going to need a couple screws. We'll get into the details on those in a bit. But to start off with, you're going to need some 22 gauge wire. You're going to need black, red, and white. Set that out of the way. Now, for me, I'm lucky. I have a big work mat on my bench, and it's actually designed for fabric. Works great for this stuff. Not good for high temperature. If you're soldering on it, you will melt this. Get one of the nice silicone ones. They're super cheap. And these are wicked expensive. But it works well for what I'm doing, and it gives me a nice 1-inch reference grid that you guys can see at home, which makes it a little bit easier for you. So what we're going to do is we're going to lay these out. So we've got black, white, and red at 22 gauge, and you're going to need to cut these off at 42 inches long. That's 107 centimeters. So I can just lay these right out on my bench here. And go out to 42. Okay, so that's our spot. Grab my little cutters. By the way, totally useful thing to know. Hakko is known for soldering irons in a big way. They also make these cutters, and I love them. I use the hell out of these. I have tried a bunch of different little cutters. Like I tried the Kleins. I'm a big fan of Klein hand tools. Their little cutters suck. But Hakko, oddly enough, makes a really good pair. And just for your reference, they're the CMP? Yeah, it's CMP-170. I'll put a link to these in my Amazon store. I think that's CHP. It's hard to, I'm under really bright lights here. We've done some major upgrades to the studio. I'm going to say those are CHP 170s. There'll be a link to my Amazon store in the description, and if you go under the tools I use, you'll find these there, because I use the hell out of them and I like them. So we've got 42 inches of red, black, white 22 gauge. This is the nice silicone wire, and now we're going to start getting into terminating these for the limit switch. Okay, so the first thing you're going to want to do is strip the ends of your wires. You're going to want them all stripped at about 1/4 inch, 3/8, give or take. So we're just going to strip them about that far. And then give a good twist on the ends. Okay, so they should all look like that. And then we're going to crimp these on there. Now, if you have terminals that are exactly like this, they're all pretty similar. You want to make sure first that your terminals fit your thing. They do. And inside these terminals, the area here has the metal collar in it. The area back here is just a shroud. So don't crimp back here, just crimp up here, and don't crimp up here, you'll have a bad day. So you're gonna apply your crimping force here. I'll show you how to do that. All right, now I'm just using a generic pair of Klein crimpers. I'm not using fancy ratcheting ones, and this will work fine for this application. So it doesn't matter, all your terminals, your crimp connectors will probably be the same color. Now you can see if I put that in there, it's gonna stick way up in. But I've got a really tiny little hole. So my strippers are calibrated for doing big 12 gauge wire, because I do a lot of work on larger stuff. So I'm going to trim these down because that's actually too much stripped off. So what we really want is about there. So I'm just going to cut that extra off, and that leaves us back at 1/4 inch. But it's easier for me to trim the wire off a little bit than it is to readjust my crimpers, because that will really annoy me the next time I go to wire up an outlet or something, and that will just suck. So I'm going to put that in there and make sure it actually goes in, and crush it a little bit, because you can kind of see the black insulation of the wire. You want to make sure that's down, you don't want the black insulation under. You don't want the black insulation to go past this line. You can see the shiny metal tube inside. Don't put insulation into the tube, just bare wire. And then we crimp these down really tight. Make sure your wire stays all the way in. And squeeze that with everything you got. Oh, because you can't squeeze too hard. Like, I mean, if your handles touch, if you're like some 200-pound gorilla, then cool. But you should be just fine. You're not going to damage this with this style of crimper by overstirring it. Then give it a little tug and make sure you're good. You want to do a tug test whenever you do a crimp connector, especially a crimp connector. But even like a Wago, wire nut, stuff like that, always do a tug test. So on my crimpers, you'll see I have this big divot pin here, and I've got the flatter one here. And this says INS and non. This is for insulated here, and that's for non-insulated ones. If you use that, it can puncture through your insulation on the outside. It won't hurt anything, but if the wrong thing touches that, it can mess things up in the future. So I'm going to trim that one down. Put my red in, make sure I'm all the way down. I'm going in insulated, and just over the metal band, you can see right where I'm at. I'm right over the metal band, and I'm on the insulated connector. Push my wire all the way in, and then give her what for. Just squeeze that all the way down. It's really easy with these tiny little ones. Give her a tug test, and we're good. So then we do white. Now, here's a handy trick to know on this. If you put the connector in your crimpers first, you can just, with the lightest of fingertip pressure, don't squeeze that at all, but you can hold that there, and it makes this a little easier because now you don't have to fight 3 things, you can only fight 2. And then we can put that in there, like that, and now it's already holding the thing where I want it. And then give her a squeeze. Nice and tight. Tug test. We're good. We got all 3. And we can put our crimpers away at that point. All right, so for the next step, you're going to put your switch together here. And what you need to know, these are numbered really weird. If you look at the diagram on here, it's hard to tell what's what. But what you need to know is that's your normally closed pin. That's your normally open pin, and that's your common pin there. There's numbers, but it's kind of screwy how they have it laid out on this particular model of switch. But normally closed up at the top on the rollerball side, normally open in the middle, and then common is the one down on the bottom for this style of switch. And that's pretty universal, but check your switch to be sure because there is some variation. So you're going to put your black to the NC terminal, normally closed. You're going to put red to the normally open terminal, that's number 3, and white to the common, which is number 1. So black to normally closed, 2, red to normally open, 3, and white to common. So common's down on the bottom. We'll just slide our white right on there. Okay, and it'll go all the way on. Now these are easier because these aren't the flag connections, so you don't have to mess with them or deal with screwy crimpers or anything like that. So these just snap right on and you're good. Just snap, it's good. So next we're going to do our red to our normally open terminal. And that'll click right in place. And then black up to our normally closed terminal. That's terminal 2. You should look like this. There will be a little bit of a gap if you have this size terminal, and you probably do because you're using 22 gauge wire. You can get wider ones that'll go all the way up. You could probably ram these all the way up, but you don't need to. This is perfectly acceptable. We're at very low voltage here. You're not going to get zapped by that or anything there, and so you're cool. That's what you want it to look like. Black on top, then red, then white. All right, for our next trick, we're going to install some 1/4-inch braided sleeving. That'll be this stuff here. It's on the Amazon list of parts to get, but you're going to need this again. We've used this in the past, and I'm totally doing that trick again with my medical tool. I know I got a lot of comments like, how am I supposed to do that? Tie a piece of wire to it, Like really, you can use a piece of electrical tape and a piece of stiff wire and stuff that up there and do the same thing I'm doing, just tape it together. But I have the tool. I know they cost like 800 bucks. I didn't pay that much for it. I'm low rent, but I happen to have one and I'm going to use it because if you have the tool, why not? All right, I lied. I'm not going to use this tool, the $800 Karl Storz endoscopic surgical tool. I'm going to use this one because it's even longer. This one doesn't tell me who made it. Oh, yeah, it does. Marlowe. It's made by Marlowe. And that just looks like all kinds of fun, doesn't it? So we're going to use this, I think. I think it'll work. We'll give it a shot. So we're going to need 16 inches of our braided sleeving. I'm just going to measure that out of my bench and cut it off. Oh, that's not bad. That's easy. Have that fight later. So when you cut this stuff off, you want to melt the end a little bit with a lighter. Do this on each end or it will fray. Make sure to boop the end open, squeeze it a little bit on the long axis. See how it lays flat off the roll? Squeeze it a little bit and open it up before you melt it. And then don't touch it because it's hot. So here's how I do this. Slide it up the thing, because it's a Chinese finger trap. It pushes really easily. It doesn't pull at all. Okay, but you can push it places. So if you're always working this in a push, it's not so much of a fight. Now I can take my 3 wires, run those down, because you want them all even. You don't want any lumps in the middle. Now I don't know if I can grab all 3 with this at the same time. That's the tricky part. But I figured I had a better shot of getting all 3 with this one than I did with the other one. I'll hold that. If I can slide, no. So I got to fight this a little bit. It's going to be a bit of a job. We can do it. We're smart. So my wires are now at slightly different lengths. Like very slightly, because the white one sticks up a little further. So I'm going to trim all these perfectly even. I'm going to bunch them together into a triangle. Oh yeah, that's better. Oh, I'm so smooth. So then you just, it's that easy. With the right tools. You can make the right tools. Like you don't have to go out and buy it. But you can find stuff like this old surgical gear on eBay, super cheap. Look around. Don't go out and buy it new. You can find it used on eBay and stuff like that. Really super cheap. Comes in way handy. I use stuff like that all the time. Because I work on a lot of tiny, fussy, hard to reach things, and I do a lot of models. Like if you fly model airplanes, old surgical gear is super useful. So now we have our switch on our sleeve and a long tail hanging out the bottom, and that's what you should have at this point, is your switch, sleeve, and a long tail. And then we're going to put a zip tie on here. And I have another cool tool to share with you guys. This is neat. And if you do a lot of zip ties, I recommend them. These are actually really neat. This is a zip tie gun. This is a Pros Kit CP-382. I love this thing. I got it rather recently. It's not the first one I've owned, but it's the first one I've had in a little while. So here's how you use it. We got to put a small zip tie here just to make sure that doesn't wander off. So you put a zip tie on like you normally would. Now you don't really need this for one zip tie. I'm just doing it because we've got it. Let's play with the toy. But you run the zip tie all the way down. Now you put the tool right there, the mouth of the tool, you put the zip tie in its mouth like that. And what this does is the tool pulls the zip tie down. And, watch, this happens really fast. Okay, it pulls it down, and then when the tension gets high enough, it pulls this shear down across the opening of the jaws, and it bites it off. So what it leaves you with is a properly tensioned and trimmed flush, perfectly smooth. You can't hurt yourself on that zip tie. This is the absolute most awesomest thing ever if you're lacing up a big project and have to do like a bajillion zip ties, because I have to do stuff like that pretty regular. If you're doing a big wiring harness, like if you're working on a boat or a car or something like that, a Tesla coil, high voltage project, you got a million zip ties in a thing, one of these are pretty awesome. So now you know, zip tie gun. It's one of those tools that most people don't have, but if you do a lot of electrical work, it's super handy. So we've got our whole assembly made up. This is our sub-assembly for the J3 limit switch. Now all we gotta do is bolt it on. For this, you just need a pair of M3 by 14 screws, and I'll show you where they go. So first, let's take a moment and remind everybody how to measure screws so that you know you got the right ones, because when you get the hardware kit, they don't come labeled. So I'm making a point to show you guys how to do this. If you have a pair of calipers, thus, there's two numbers in the screw. These are M3 by 14s. So you open it up, you're going to be just about 3 millimeters, because it's M, so it's metric, M3. And it's not going to be exactly 3 millimeters. It's 2.9, so it's closest to 3 millimeters. And then, now this is a panhead style screw. It's a Phillips screw, but it's a panhead screw. So for a panhead, you measure from under the head to the bottom of the screw. And we got 14-ish, close enough. Screws are not typically made to ridiculously high tolerances. If you're just buying generic, you bought it at Lowe's, Home Depot, your local hardware store, they're not going to be made to crazy high tolerances. You can get some screws that are just off the charts, but for whatever you're going to probably find and the stuff that comes in a kit, these are all just generic jelly bean nuts and bolts. So we're going to turn this around to this side. Make sure you guys can see that. There you go. All right, so we're working on this side of it, because we're going to actuate to a thing out here. And you got a bunch of holes down the side. These holes along the edge are for your cover plates and stuff. These two extra holes inside are for your switch. And the switch is going to go just like this. You're going to have one screw in, because I want to be really clear on this, because I'm going out of order because I don't have my cover plates on. So that's a little bit weird. Normally that hole would be occupied, but I'm doing this without the cover plate. So you're going to go into those two spots. That's where you're headed for your screws. So we'll take those out of there. These are going to be a number 2 Phillips here. You want to make sure it's pointing the right direction, so it'll be like this with the dingle arm going up. If you ever watched the turbo encabulator video, and if you haven't, check that out on YouTube. That should be the next thing you watch. It's classic. But the old turbo encabulator video, the gentleman doing the video talks, he specifically mentions about the dingle arm as one of the things. And now you know what a dingle arm is. It's that right there. That's your dingle arm. Okay. So we're going to screw this down, not crazy tight. This would be a good place to use a little blue Loctite, but we'll be doing that in a future video when I take half this thing apart and Loctite all the things. All right, so now we've got everything where we want it. The next step is just to route this wire, which is pretty easy, and we're going to use a couple zip ties to do that. So we'll get our awesome zip tie hand cannon for this. So you want to do this in a specific way. You want to wrap it around the back of that motor. So what I'm going to do is actually zip tie it right to the motor housing. I'm not 100% certain this is where we're going to want these in the end, but it's easy to change. So that's one of the cool things about zip ties is you can experiment a little bit because it's no big deal to change them around. So that one's on there. So we're going to make a turn here, which means I'm going to put another zip tie like that. Zip ties are cheap, use lots of them. I think I might be able to get one around that too. Now, if you zip tie, when you come across here, I want to show you this really clear. Right. There's no easy way to tilt the damn thing. Right where you come across from the gearbox to the motor, there's a shear line here, and they're about even at this point, but they jump off at the corners. So if you go across in the middle, you're all right, but you don't want to crimp this against a sharp edge as you go over, because if you do that, you'll make your wires angry. So make sure to keep this from this surface to this surface. You want to transition the wire over level if you're going to have a zip tie that close to the edge. You got to be careful of that. Don't do this out at the corner because you'll cut the wires. With a multi-conductor cable, you can smush them hard enough that they'll short out internally or even break wires. You'll learn as you work with wiring cable, and this comes up a lot with communications cables and stuff like that, like Ethernet is famous for it. It's draconian with fiber optic cable. There's a thing called a minimum bend radius or a minimum turn radius, and that is the tightest bend you can safely put into a cable. And that's a really important thing to be conscious of when you're doing cable routing, because if you violate the minimum bend radius, you will destroy the cable, and you probably won't even see it happening. So here I am able, with this zip tie, to do that, and now I can get a nice clean tight bend there, and I come out with the other stuff right where I want to be. I like that. So we're going to bring this around that motor. So we've come across the gearbox, made a 90 on the motor, and then we're wrapping around the back side of this motor and around the front side of the lower gearbox on J2. So we've got the J3 motor here and the J2 gearbox here. And we're going to come right around the front of the gearbox, and then we'll run these through with all of our other wires, and now it's all nice and tidy. So we're going to run around the back of the J3 motor here, and then loop under and go around the front of the J2 gearbox, and then we're going to come out the hole with all the other wires and stuff we got coming out there, and we just joined the team. So that's it. It's together. So now we've got all of our wires out where we want them to be. The next thing is to just label them to make sure that we don't lose them in the shuffle. Now you can just wrap the ends with tape and put 3 dots on them, and that'll indicate that the wires go for the J3 switch. What I'm going to do is actually, because I have it, make a fancy label. J3 switch. Because you guys got me the fancy label maker, I like using it wherever I get the chance. So we're gonna straighten these all out, make sure they're all nice and even, because you want to keep them all nice and even, and you want to, when you put the label on like this, you want to tape them all together, because you're probably going to have to pull this through a hole, a tiny little hole at some point, and you want to make sure that all the wires for that thing, in this case the switch, but this is true of motors and encoders and anything else, you want to make sure all those wires stay together, because you're going to need those wires together at some point. So there we go. We're all done. We made a thing. That's pretty cool. That's a lot. It's a lot of video for something as simple as a switch, isn't it? But I really want to take the time because I don't know what you know. Now, some of you will watch this, and a lot of people won't even have to watch this video. They'll look at the manual and be like, oh, put the J3 limit switch there, a little bit of sleeving, okay, cool. And you might need to watch it to get the details of the routing or something like that. But I'm making these videos assuming that you don't know anything at all because I don't know what you know. So I have to go really simple, and it takes a lot of time, but it's worth it because I want everybody who has the desire to build one of these to be able to. This is an amazing kit. It's what Chris Annan has done with these is absolutely astounding. The amount of work that it took him to make this kit, to write the manual, to shoot all the pictures and all that, that's epic. And I want to make sure that everybody who wants to get one of these kits has the ability to put it together with as much help as I can give them. I'm no robotics god, but I'm trying really hard to help bring everybody along on this because there's a lot to learn. It's an amazing project, and it really gives you the opportunity to grow and evolve as a nerd. So I really want to help you guys be able to build this. So thank you everyone for coming along for episode 25 on Project Archi. We'll be back for more fun with wires and heat shrink and crimping and soldering and all manner of fun in episode 26. So stay tuned because that one will come out pretty quick. Thank you ever guys. You are awesome. And I will see all of you next time. Project Archi, episode 25, take 1.